So welcome you all, and today I'm having some question on the screw job. Okay, as we all know that there will be a screw job having number of elements that are been assembled like this. Okay, and this will be the shape as you have seen in many cases. Okay, and having one arm, it will be connected to this part, and here there are some threads, internal threads, and sorry, this is external threads, and here there will be internal thread. So when you will make the revolution of this arm, it will start to lift, right? So that mechanism, as we know that. So now let us see how to calculate the work done and the power required to make the operation of this element. Okay, so the screw jack is rotated at a speed of 30 rpm. It means this is the speed of the screw jack. Let us say n is equal to 30 rpm. Okay, and by applying the force of 200 newton, so the force will be applied here to this arm, having a force, say F is equal to 200 newton. And let us take this distance from here to here, the length of the arm, you can say that is, we can take 0.5 meter. So now we have to calculate what is the work done per revolution and the power required for the this elements. Okay, what is the power required to make the one revolution? Right, hope the question is very clear to you. Now first, this is the where the rotating element and the torque it will be produced, or the torque it will be developed in the material. So the torque T is equal to the force into the length. Force into the length you have to calculate first, then the work done per revolution. Okay, work done per revolution you have to calculate. That the formula is torque into the angle. Okay, so now force is mentioned as 200 and length is 0.5 meter, so it will be 200 into 1 by, okay, so you got 100. Force is newton and distance is in meter, so 100 meter. Now work done is equal to torque as 100 and angle. Okay, so angle of per revolution, it is 2 pi. So from here 100 into 2 pi got 628.3 meter work done. Now what is the power required? Okay, let us calculate the power required. Power required is equal to work done per second, or work done per revolution. Work done per revolution into the revolution per second. This is equal, work done per revolution is W and revolution per second newton, speed by 60. Work done is equal to 628.3 into this one 30 or 300. What is the speed is given here? 30 rpm. Okay. 30 by 60. Now let us calculate what is the power required. So this will be in watt. Okay, let us check. 628.3 into 30 by 60. Got 314.2. Okay, 314.2 watt, or you can say 314.2 Newton meter per second. This is the answer. Okay, so thank you for watching.